What you're working on for Everyday Math Lesson 9.6 today is a little bit different than what we've been doing. It's still algebra, but you're actually doing some physics as well. And you'll be working with lever arms or lever arms. It can be said either way. And they'll have diagrams set up for you which will look something like this. And what this represents is something that's hanging from a ceiling like a mobile or something like that. And you'll have weights on each side. It can also represent something like a teeter-totter if it was turned upside down with a person's weight on each side. The center point where it turns is called the fulcrum, and then you have an arm which is called a lever arm, and a mass off the bottom which they are calling the weight. These are first-class lever arms because they always have the fulcrum in the center. There are other versions which we won't be working with today. And what you'll have in your equations are numbers and letters in place of the variables I have here. Your equation you'll be using is the weight on the left side of the equation, and the distance also on the left side multiplied together must equal the weight and distance on the right hand of the equation because it must balance. In order for a mobile to work, it has to be balanced on each side. Okay, so when you have problems today, most of them will look like this where the fulcrum is in the exact center. Sometimes you'll have a fulcrum that's not in the center. It's a little off from the center of the lever arm. And so the weights will change because one side would tend to want to rise or lower if it had a different weight than the other side. So you have to move the fulcrum one way or the other to make it balance. So you'll be using algebraic equations to find the different weights in this equation. So when you're doing problems where the fulcrum is not in the center, the weight of the rod is taken into account, and the distance from the center of the rod to the fulcrum is also taken into account. In the problems for today, however, they're not using the rod as having any weight, so you'll just have the rod as weighing 1 unit of our measurement. So our formula, the only thing different with this version is in our formula we have the same items on each side, except for the weight of the rod and the length of the lever arm is also included. This is what it will look like in a problem. This is very similar to the one you'll have for homework today. In this problem, you have a lever arm which is not in the center of the rod. It's a little bit off from the center. So you'll plug these parts into your equation just like you would the other problems that we'll be working on today. So for large W on the left side, you want the weight hanging on the left side of the fulcrum. In this case, it's 5b, so you'll have variables in the numbers you'll be using today in writing the algebraic expressions. So you'll write that on the blanks that are given to you. You'll write the distance from the lever arm. In this case, it's 4, and you'll write that on the line. And you'll do the same thing for the right side of your equation. The weight on the right side and the distance from the fulcrum, I think I said lever arm, the distance from the fulcrum on the right side as well. And then what you'll do is you'll use the formula to multiply these together. So you'll use this formula, plugging in the numbers that you write on the blanks, and you'll come up with an answer or solution for what b equals in this equation. So basically you'll have blanks that you'll plug numbers into, and then you'll solve for your variables. So we're writing and solving equations based on the formula it's giving to you. The formula just happens to be with lever arms and fulcrums, things like that, that we do in physics. Today we're working on Math Journal pages 341 and 342. It's challenging, but there's not a lot of work, so you may end up with extra time to finish some of the other pages that you need to work on.